Do you remember?
The time it takes the red blood cell to travel body.
And if we think about that, what that is telling us is it's going to give us one cycle of this heart doing a contraction and a relaxation, which is taking place in atria and ventricles. Okay? Now, the cardiac conduction system, the part that you see over here to the right, what we're going to learn is we're going to talk about that SA node, the AV node. We're going to look at now one part that we'll also learn from that AV node where it comes down and begins to branch. The term for that is the bundle of His, H-I-S, okay? And then it begins to branch. And so those bundle branches that came down and turned upward, okay, and led to the Purkinje fibers. And what this is the conduction system to get that heart to contract and relax. Okay, so that's what we're going to learn. So in looking at what we have from Ayana, and I love this. Thank you for sharing that too. And I'll thank Dr. Ms. Neal also. Now, in looking at what we've just gone through, okay, so we're definitely, hopefully, at this point, because we had looked at, in chapter 19, we had looked up to the point where we had talked about atria, ventricles, okay? We had talked about these semilunar valves. The semilunar valves are what's heading into the pulmonary trunk and the aorta. The atrioventricular, like I mentioned before, the valve between an atria and a ventricle. And on the right, try, on the left, two. Let's see, we had looked at the picture, we had looked at some of the valves, we looked at some of the and we had looked at the coronary circulation. So that was pretty much the point that we had made it to on Thursday of last week. So now, if we're looking at this particular information, okay, the way that we will be looking at this cardiac conduction system and how we're going to have a contraction and relaxation. What happens is we're going to see that blood that will return to the heart, okay? Blood that returns to the heart, it comes in from vena cava. We have our superior vena cava, our inferior vena cava, and then located on the little side is going to be, do you guys remember us in the coronary circulation talking about the coronary sinus? Okay, so we have that point where we have our coronary sinus. Okay, now blood is going to return to the heart from these three areas. It's going to make its way into this right atrium, all right? Now, it's going to flow from that right atria to the right ventricle. In the right ventricle, it will move to my pulmonary trunk, into this great vessel, okay? The pulmonary trunk is how they usually refer to it. because we have right and left lungs, that's why you're going to see it go from right and left into the right and left lung. It will get oxygenated and return from the lungs. But now note, because I have a right side and a left side, but each of these pulmonary veins empty into the left atria. Okay? So the blood empties into the left atria, to the left ventricle, goes into my aorta, and then begins systemic circulation.
So it starts from the right side.
We are starting from the right side and carrying it to the aorta.
Did you say that it enters from 3 places?
We're going to have it enter from our superior vena cava, inferior vena cava, coronary sinus.
Coronary sinus is the blood flow from the heart. Right?
The blood flow from the heart. That was the part that was our coronary circulation. Okay? Meaning it fed the heart muscle itself. Okay? Now, as we move in further into our chapter, okay? Because as we move further into our chapter, we are now going to look at what happens to make the heart beat. All right? One of the things that I've tried to point out quite a few times, the heart is innervated. However, it does not require the nervous system to beat. Okay? The heart is all to itself in setting its pace. Okay? So, we'll come back to this in just a second. Let's take a peek at what's going to happen, because she pointed out the sinoatrial node, atrioventricular node, bundle of His, the bundle fibers, bundles, and then Purkinje fibers. Okay? Those are important. So, let's take a peek at what's going to happen. Now, do you guys remember, in looking at heart muscle versus skeletal muscle, do you remember that from part 1 and the differences? Yes, no, maybe?
I do not remember the differences.
Skeletal muscle strength.
Okay. If we look at skeletal muscle, okay? Do you guys remember how skeletal muscle looked like tubes, had the striations in it? Okay? However, a skeletal muscle, and the longest one is our sartorius, okay? And that entire length, all right? So if everybody can kind of see my bad example here, let's say that from my sartorius, I could pick one fiber and hold it up of that sartorius, okay? That was one cell. That huge, long fiber. And along it, it was, of course, multinucleated. Do you guys remember that? Now, in heart muscle, it's still striated, but it branched. all right? And 1 to 1 was 1 cell. Everybody remember that? Meaning it's got one great big huge nucleus, and then those mitochondria, woo, they're huge, okay? Because this is an organ that's working 24/7. So 1 cell, okay, is a cardiomyocyte, all right? So this heart is made up of these individual cells, all right? So their ability when they receive the signal, their ability to pass the ions. Now, what do I mean by ions?
Salts.
My salts, my pluses and my minuses, okay? So once again, we're going to go back to calciums, sodiums, potassiums. All right, so everybody remember those, okay? Their ability to pass those salts, which generate electricity. Do you remember that in skeletal muscle? How do we know it generates electricity? No, tell me. Go ahead.
Well, I think about like EKG stroke.
An EKG, also known as an ECG, all right? And you can put the little 6 leads on the chest, you put leads on the wrist, you put leads on the ankles. They turn the machine on, and then they turn the machine off, literally. Because they only need to look at 1 heartbeat. And they can do that because the machine picks up on the electricity. Does that make sense? Now, because we have those muscle cells, okay, on average, heartbeat's about 75 beats per minute, BPMs, all right? Our heartbeat is myogenic. Myo means muscle, genic, genesis, beginning, okay? Myogenic. It originates in the heart, ends in the heart. And because it is auto-rhythmic, self-auto-rhythmic rhythm, all right, it sets its own pace. Electrophysiology. Ever heard of it? This is electrophysiology. It's a huge area of study for people who go into being cardiac doctors. Why?
Appropriate rhythms, maybe how to like remedy things that are.
I'm kind of glad mine has the appropriate rhythm. Okay.